Hey everyone, good morning, good afternoon, good evening, wherever you're joining us from, and welcome to this webinar hosted by Statsig in collaboration with Bell Statistics on sequential testing. I'm Sid from the product marketing team at Statsig, and I have with me today Michael Makris, our data scientist, and Allon Korem, who is the CEO and founder of Bell Statistics, who's also a partner of Statsig. We have a really interesting topic today on sequential testing. Um, I will have both our presenters introduce themselves in just a moment, but I just want to get a couple of quick housekeeping items out of the way as people trickle in. The first is that this session is being recorded, so within a couple of days, we'll send you all the recording of this event so you can evangelize this internally with your colleagues. And the second is that I've turned on the live chat and Q&A on the Zoom panel, so you can engage with us on the chat throughout the webinar. And it would be awesome to get your questions throughout. We'll try to answer them then and there, and also set aside some time at the end of the session to take them to do like a live Q&A. So the session is for about 40 to 45 minutes. We'll have like a candid conversation on sequential testing, discuss different approaches, um, two different approaches, and also just why this is important in A/B experimentation. Michael will focus a bit more on Statsig's methodologies and implementation, and Alon will be giving you a more high-level overview. But do keep your questions coming throughout the session because we want to make sure that we can what's top of mind for you folks. We want to make sure we address that. We also had a couple of questions come in during registration, so we'll answer that as well. Um, so uh, let's get started. I want to, hand it over to Alon first to do a quick intro. Alon is the CEO and founder of Bell Statistics. I also want to ask you, Alon, like a lot of the folks who registered loved the title of today's webinar, Test and the City. I actually got a couple of questions as, hey, we love the title of the webinar. Just wanted to say that. So maybe also let us know, how do you come up with these titles that makes you know these um, these statistical concepts more fun and engaging.
Thank you, Sid, for the introduction. Yeah, well, first of all the credit goes to my marketing manager, staff. I have nothing to do with the titles, but I like them very much. And thank you for the feedback. Yeah, so I'm a statistician and I'm the CEO of Bell. We provide experimentation and MMM advanced analytics services to companies in Israel and abroad. We help them do A/B tests better, more reliable, faster, and much more in scale. Um, that's, I would say, for now.
Nice. Michael is our data scientist. He works with a ton of our customers to often co-create new statistical methodologies. He works on sequential testing. But Michael, do you want to give a quick intro on your role at Statsig and just your background before?
Yeah, absolutely. Thanks, Sid. I've been at Statsig for about 6 months now. I am a senior data scientist, and like you said, I've been working for the last 6 months on basically expanding our toolkit for different analysis methods. Sequential testing and improvements in our sequential testing methodology is one of the things I've been working on. I came to Statsig from Uber. I worked there for 8 years. I was a product data scientist, and so I was very much a practitioner using experimental tools and software, focusing less on like the theory and more on like actually making product improvements. And now I've made the switch into more being, working for Statsig and building out the platform for others to do so as well.
Nice. Really excited for the conversation ahead. Two really experienced professionals who worked on this sequential testing and other stats methodologies. So, to get things started, Alon, can you help us set the stage? Like, give us a brief overview of what is sequential testing, and why is this even important in A/B experimentation?
Yeah, sure. So sequential testing basically is conducting A/B tests with the ability to pick at the data, meaning to look at the data on a daily basis, hourly basis, depends what you want. Now, many or some of our audience might say, oh, we already do that. So when you can currently today in the online industry, you can look at the results every day and you will see some p-value and some confidence interval. But if you are using what we call the classic statistical tests, like the t-test and the z-test, which are the most popular one, and you are looking or picking at the data on a daily basis, you're doing something wrong. That something wrong is called inflating the false positive rate. If you can give me like a minute or two, I'll just explain what it means to inflate. What is the false positive rate and why is it so bad, or why is it wrong when we do that if we are not doing sequential testing? So the false positive, let's assume for the purpose of the example that there is no effect. Usually it's really easy to think about an AA test. So we have 50% of our users receiving variation A and 50% of our users receiving the same exact experience, also A. So there's no difference in the experience between both groups. In that case, this is one of the most rare cases when we know that the null hypothesis is true. In that case, we would expect that in most cases, there will not be any significant results because indeed there's no difference between two groups. What happened, and that's fine. We would actually expect that, I don't know, about 5%, maybe 10%. This is really depends what false positive rate you choose. That would be the percentage of time that you will see significant result, falsely significant results. This is the false positive rate. What is the percentage of time that you see falsely? There's actually a difference between the two groups. Now, when you peek at the data, this specific false positive rate gets much higher because the classic t-test and z-test are designed to be analyzed only once. So when you analyze the result more than once, twice, 3 times, 4 times, you will see more frequently significant results when there is no difference. So now, some people might say, okay, I don't really mind about inflating the false positive rate. I don't even sure I got it, what Allon just said. But I tell you what is the worst thing I see in companies that are picking at the data and not using sequential tests. And what I see is that they are losing their trust in the data. And why is that? Because one day they look at the results and they see significant results. The day after, when they look at the results, they see that results are not significant, and so on. So the results sometimes becomes significant and not significant, and it happens many times. It will happen much more frequently when you pick at the data and not use sequential tests. And that makes people lose trust in experimentation in general and in making database decision in general. So this is the problem when picking. Sequential test solves that problem. Sequential test is just, you change the statistics, you change the statistical test in order to be able to pick at the data. This is like in general what it means. And it gives you the ability to stop earlier if needed. So if results are seems really promised, you can stop before you reach the sample size. But you know that you have all the guarantees you had in those classic tests, the false positive rate, the power, and so and so.
That's interesting. So it sounds like a lot of companies make this mistake. Is that what you've seen, Allon and Michael, if you also want to chime in? Like, it sounds like there is this peaking problem. A lot of people, despite which they, end up looking at the results and making like an early decision without it being a sequential test. Is that so? Do you see that happen with either, some clients or customers?
I see. We had a webinar just, I don't know, a month or 2 months ago about the most common mistakes.
Yeah.
I think this is one of it will be the first or the second one. And just because picking is inevitable in online experimentation, right? If you have an app or a website and you have a dashboard of test results, you'll get the results all the time. I haven't met yet a company that do not show the test result until you reach the sample size, or wait until the analyst is ready to analyze the test. You have it in your face. You can just get into your dashboard, whether it's Tableau or Redash, or using a vendor Statsig. So you're going to do that anyway. There's nothing that's, so this is why it is so common.
Yeah.
Yeah, I'll echo what Allon said. Like everything he's been getting at is, I think, indicative of this idea that, like, at the end of the day, the statistics are about like giving you, like, they show you a number, but we as humans are the ones making decisions. And so it's our propensity to like see a number that looks good. And so therefore want to be like, oh, let's end it early. Let's claim a victory. That's what leads to these false positive rates. It's our own bias towards a positive result saying, then we make a decision. And that can only increase our chance of getting it wrong as opposed to waiting to the end. In a perfect world, we'd all be able to wait to the end of every test, our planned duration, look once and make a decision. And then all of our like false positive rates would like hold, our power would be as we wanted it to be. And we'd be able to have confidence that, like, if we're always setting, significant levels at 95%, then we're always getting it right 95% of the time, kind of thing. That's not the case. That's not the world we live in. You asked about certain customers, and it's worth pointing out, like, not everyone's tests are the same. Depending on the qualities of the test, what you're testing, what your company's priorities are, there's a different weight towards, like, do I need to make a decision fast? Can I afford to wait to the end? Imagine like the classic drug trials example where, there is like people's health on the line. And so you're really interested in making a determination about like safety and efficacy as soon as possible. That's actually where sequential testing comes from historically. It was a large part of the literature comes from like drug trials. Or imagine the sort of more modern example of like a newspaper or news site. A lot of news sites are under pressure to, like, they want to choose a headline. Are they testing A headline or B headline? And that news article is only relevant for so long until it becomes stale. And so you need to make a decision fast in order to capitalize on the sort of headline that's going to bring more views and reads. These are situations in which being able to know faster and make a decision faster is super valuable, but that also increases your propensity to make these sort of errors by your own bias towards seeing a positive result. And that's where like something like sequential testing can be super valuable.
Yeah, I love these examples. I think we've also seen, like, I guess in some situations like e-commerce sites or, companies where they have like, some real thing like a revenue to lose by, maybe taking too long to make a decision. Maybe in those situations as well, it could be useful, right? All right, so getting into more of the, the techniques of doing sequential testing, because I think it's pretty clear that, this is a really relevant and important technique for in different scenarios, obviously different types of experiments, like you pointed out. Allon, can you talk a bit about, what are the two techniques of sequential testings in terms of like the stats methodologies, and maybe touch upon, at a high level, where can you use these, and also what are the primary advantages of these techniques?
Yeah, sure. It might take me a few minutes, but in general, it is important to say that sequential testing is a framework. So there's lots of sequential tests inside these frameworks. There are more than two, but I think that two are very popular. Is the MSPRT, and the second one is group sequential testing. There are more. There are Bayesian sequential testing. There are other frequentist sequential testing, but I think those are the most prominent and the most popular one that are being used. MSPRT, as you know, it is implemented in Statsig. It is, I'm not going to talk about statistics at all. I'm just going to talk about, I would say, the procedure, or the how you what it allows you to do. So no statistic theory at all in this explanation. So MSPRT is a sequential testing test that allows you to analyze the results whenever you want. You don't have to set a sample size. You don't have to analyze the results every once in a while. You can do it. You have the flexibility to do it whenever you want. Theoretically, after every user gets into the experiments. Okay, and this is like a very good part of the MSPRT. And it's really easy to use and easy to implement in general. Both are relatively complex, but it is relatively easy to use and to implement. The group sequential testing, in order to do group sequential testing, you need to have to set the sample size of the test. So you need to decide what is going to be your sample size when you want to end the test, whether the test results are significant or not. And you have the ability to set some exit points. So you can choose 5, 10, but you don't do more than I don't know, 20. Usually it will be up to 20 times that you will be able to test, to analyze the results and possibly stop the experiment. And you analyze the results once you reach every exit point or every interim analysis, what we call. So this is in general how the framework of each one of them. Oh, there's one thing which is important to mention. If you do plan a test in group sequential test and you have your sample size, usually you also have what we call MDE, which is the minimum detectable effect, which means I want to be able to detect 3% uplift or 4% uplift and so and so. Doing that, having this MDE allows you to have what we call futility boundary, which means that you might stop the experiments before you reach the sample size, not because you're winning, but because there's no chance to see a 4% uplift significant results. So this is one, I would say, feature that you have in the group sequential test. So in general, these are the two I think the most popular sequential tests out there that are being used. And I think that you can, by the description, understand this bit the disadvantages and advantages of each. I would maybe say like 1 minute, 30 seconds about it, and then we give Michael the opportunity to say as well. So in MSPRT, you don't have to plan a test. It's really easy to use, and everyone can use it relatively easy. It's really easy to implement it, and to use it, it's really hard to make mistakes. Group sequential tests, you have to plan a test. But if you do plan a test, then it might be more powerful. But, and it's an important but, it depends how many times you are planning to analyze the data. If you want to be able to analyze the data after every user, if you're capable to do that, then MSPRT might be more powerful in some cases. So there is no right or wrong in general when it comes to sequential tests. It a bit depends on the culture, who is going to do the A/B test, and how frequent are you going to analyze the results.
Yeah, Michael, do you want to come in to talk a bit about why the MSPRT method might be more suitable or more useful? Allon obviously touched upon group sequential tests. Do you want to give the perspective of from also maybe from a Statsig point of view, but where MSPRT might be more suitable?
Yeah, absolutely. I'm going to echo a little bit of what Allon said, but I'll present it from the from our perspective and how we think about our customers. So reiterating that MSPRT has a little less like planning involved. The idea with MSPRT is that you will conduct your hypothesis testing like you normally would for like standard hypothesis testing. You should run a you should still run a power calculation ahead of time and plan your XP. Let's imagine we're setting our XP to the sort of assumption of like a 2-week plan. We've established our MDEs, we figured out how much sample size we need, and we turn it on and we proceed. The idea with MSPRT though is that, as we've talked about, you can start looking at the results right away. The way MSPRT works is we just naturally adjust your confidence intervals at Statsig so that the chance of you making that incorrect declaration that the experiment is over when it's not goes way, way down. And so you maintain your overall error rates. We do it like this at Statsig via via MSPRT because we're trying to make experimentation accessible to everyone. That's one of the sort of core reasons why Statsig exists. And so we chose MSPRT because that lowers that barrier to entry for all sorts of companies and all sorts of practitioners to run experimentation effectively. And so we didn't want to add additional steps in having to pre-plan out when you're going to check in on your experiment, sort of spend your alpha, as we say in the industry, on like specific checkpoints. Instead, we wanted to be able to say your experiment results, if you're looking at them, are trustworthy at any time you look at them. And so that's the sort of core reason. There are trade-offs with MSPRT and group sequential, and I think Allon is actually going to talk about that. That you give up a little bit of power, but for a lot of flexibility. And that was one of the core reasons why we went with the MSPRT implementation. Does that make sense?
Yeah, no, I think it's interesting to like get that perspective also on like, why Statsig chose, this methodology. I know we have a couple more, questions that we wanted to cover on this topic, but I think it might be good to like pause and take a couple of questions from the audience, which are relevant at this time. The first is from Tomer, who asks, what is the minimum group size in each test? And can I use this type of test when my groups are not normal distribution? Michael or Allon, do you want to address that?
Yeah, I don't mind, whatever, Michael, you prefer.
I mean, I'll take a stab at the first. I'll take a stab at them. I would say like, unfortunately, there's never going to be a single answer to what is the minimum group size in each test. There in literature and in the real world, you will find hypothesis testing on 10 people per group, and you will find companies that run experiments on literally millions of units. I say people or units like per group. You could imagine if you were able to split the entire world up, like if you're a Facebook or a Google, I bet they have experiments with billions of people in each group. It really just depends on your situation. The amount of group, there's always going to be a trade-off between your group sizes, like how many people you demand of your test before you can make a result, and what is the detectability of any changes you're looking for. And so if you're willing to accept the idea that you'll only be able to detect huge changes in your metric or nothing at all, you can have really small group sizes. And so that's a constant trade-off in experimentation, and there's never going to be a right answer. It really depends on your use case, your sensitivity to being able to make decisions. Allon, do you want to take the second one about normal distributions?
Yeah, first of all, I loved your first answer, and I'm happy that this session is recorded. I could use it for, if you'll allow me to help with other clients. I got another normal distribution. Well, I wrote a blog. I think we mutually did it. Actually, it was like a week or two ago with Statsig. It's a co-article that we did about normal distribution. And the problem, it's not the problem. I think that the question comes from people that learn statistics in the university or college, and they learn that you need to have some assumption about normal distribution of the data, of the KPI, before you do a t-test, for example. And like in general, it is true when the number of observation is really, really small. Like if it's really low, 10, 15, 20, then you really care about the distribution of the data. But in general, in online experimentation, when most of the experimentation are at least several hundreds or several thousands in each group, then you don't need to assume normal distribution of the data of the KPI. The t-test is really robust to that assumption. So there is some kind of formula, but usually if you are not sure, if you really are a bit, I don't know, worried, what you can do is open, I don't know, 100 AA test and to see if you reject the null hypothesis more than you would expect. So if you have your alpha set to 5%, you don't want to reject the null hypothesis more than on average 5 times. But I'm telling you, don't do that. You don't need to do, just trust the statistics. When data is big enough, when it's more than several hundred, several thousand, no need to assume normality of the KPI or the data.
Yeah, and I just dropped the blog that Allon was referring to on the chat. It's called "It's Normal to Not Be Normally Distributed." So for those interested, take a look at that. Might be helpful. I think it might be worth, just like hanging on in this topic of just the trade-offs between the two techniques before we move on to the next question. And I think we have Shri from our audience who asks if you could just expand a little on the trade-offs between MSPRT and group sequential testing. I know you both like gave the individual perspectives of each technique. Do we want to just maybe summarize at a high level? Maybe Michael, if you want to go first and just talk, just sort of distill those insights, and then Allon, you can chime in as well.
Yeah, got it. And just to make sure, we're curious about like what's the core differences when implementing the techniques?
Yeah, it sounds like the trade-offs, like when would you choose one over the other, and maybe more just talking about the advantages again, maybe of
Okay.
yeah.
I mean, so I'll be cheeky, but like, hey, if you are using Statsig, one reason to use one is because it's built right in. MSPRT is built right into the Statsig platform, but I know not everyone uses this. So I would say that for me, I'm going to reiterate what Allon said, is that one of the core differences is going to be your, what kind of test plan you want to implement. If you are very sensitive if you have a high desire in your organization to be able to check early and often, you want an unlimited capability of checking in on results. I would definitely err towards the MSPRT side of things. MSPRT is this continuous monitoring framework in which you can look as much as you want and you don't risk increasing your chances of making the wrong decision too early. Group sequential testing, on the other hand, because it establishes a clear framework for checking in at specific intervals, and then only at those intervals if you want to maintain your predefined error rates, it does have a slightly increased power, but you trade off your ability for continuous monitoring. And so depending on your use case, that one might be the better solution for your company. I'd say the other major decision point for me, if I were choosing between the two, was going to be how much knowledge I had ahead of time of what I expect in this experiment and situation. Group sequential testing, because as part of that planning process for what I'm going to check in, you have to make some harder assumptions about what the distributions of the data might look like once you start to run the test. MSPRT is a little bit more relaxed in that you can start it running and then you can sort of set it and forget it. And so if you don't really have a strong belief in what you're going to see, I'd again err maybe towards more MSPRT. This is all just to reiterate why we chose MSPRT at Statsig as opposed to the perfectly valid method of group sequential testing. We're designing a platform that's a little bit more built to democratize experimentation for companies who haven't done it before and may not have a deep bench of knowledge. And if you're a little unsure about your methodologies or you're still learning about traditional hypothesis testing, I would advocate maybe starting with MSPRT because it's a little bit more forgiving for companies just getting up on their experimentation journey.
Yeah. All great points there. And Allon, do you want to is there anything you'd like to add to that? And if you also have any real world examples where you've seen either techniques or just sequential testing at large, how it's helped with decision making to sort of like tie it all together.
Yeah, I don't have much to add. I think that it was right on spot, like in terms of really, I think like the difference of when would you like to use, not only the differences, but when would you like to use each one of them? Well, we implement sequential testing with our clients and customers, and it really makes a difference in terms of it saves. And we didn't actually talk a lot about why to do sequential testing in general. Like you wanna I don't know, control the false positive rate, but you get the big advantage is that you can have a much shorter test. So you could short your test like on average in dozens of percentage, between 20% to even can be 60 or 70%, depends on the test. And that what we saw with customers. So we implemented sequential testing, and you can see that many of their tests are getting much shorter because the results are significant. or because they can declare that there's no chance to have any significant results. And it really makes it's the I don't think I could overstate the impact that using sequential testing can do to a business in terms of, first of all, gaining trust in the methodology in what you do, and second, making your tests much faster without compromising on the I don't know, statistical obligation you have for false positives or other mistakes. So sequential testing in general, I would recommend if you are doing online A/B testing, you will probably in most cases would like to do sequential tests. Now, I think there's no, I think I'll stop here, and maybe if you want, I can talk maybe later about when I would not do sequential testing, or what are you losing when you do sequential tests?
Yeah, I think, I think it might be interesting to share a quick note on that right now, because I did see both during registrations, and also we have a question on the chat, which is more on the drawbacks, or are there situations where you would not do sequential testing? So maybe, we can give that perspective as well.
Okay, first, so the big advantage of doing sequential tests is that you do not inflate the false positive rate, which means that test results are reliable and you can trust the data. The second one is that you save time, and time is money. So those are really two really strong arguments why you want to do sequential testing. Now, what are the drawbacks? I think there's one big drawback, which is everything that is related to inference, meaning that if you want to know what was the size of your impact, it's harder to tell when you do sequential testing, because the confidence interval are much wider. Let's say that you ran a test, and after several days, you use sequential testing, you plan to run one month, and now you stop. So you have, I don't know, an uplift of 10%. Now, this 10% is just the observed results you got from the A/B test. You don't know if that is going to be the real difference. The real difference could vary from, I don't know, just for the sake of the example, for 1% to 30%, for example. So when you do sequential test, you know that you have some kind of a positive impact, but to understand what was exactly the impact is really, really hard, because you stopped the test really early and you don't have enough data to understand what was the impact, what is the actual effect that you have. This is a big drawback. The second is not a drawback, but I would not use sequential testing, or I would be really cautious regarding sequential testing when the treatment that I'm giving might influence or change the time to complete the KPI. And I will give you an example to explain this point. Let's assume that you have a company and you give a discount which is limited on time. So only for the next 24 hours, you're going to get a 50% discount. Let's say you plan this test. What will happen, like what we would expect to happen, is that the treatment group, the one which will get the discount, many people in that group would have, I don't know, purchased in a week or 2 weeks from now, or maybe in a month. But now when they see the limited time discount, they're going to purchase right now. So we're going to see a big bump in revenue in the group that gave the limited time discount, and the control group, the one that is not receiving any discount, is going to be much behind. But if you wait several days, you're going, like the control group, some of the people are going to purchase, but they were willing to purchase, or they plan to purchase, but it just would have taken them a bit more time. So in those cases, when you affect the time to complete KPI, make more users complete the KPI faster, you might stop an experiment using sequential tests, declaring treatment was much better, where you had to give some time for to gather some more data regarding the control group to see that indeed there's no, what we sometimes call hangover effect, or that the control group is not completing the KPIs, just they needed a bit more time.
Yeah, I think that's super helpful to illustrate that with an example. I know we have a couple, more items we want to touch upon before we conclude, but just want to pause in case, Michael, you want to add anything to that, just on, the situations where you may not want to do sequential testing or any drawbacks.
Mhm. I think Allon's example, and I'll generalize it to the sort of example of like waiting for your data to mature is a really key one. I think it's an underestimated effect in data collection, and then how it, especially, and then in experimentation and how we use data, that effects can be immediate sometimes. Some of the things we end up testing can have longer or medium-term effects that are a little bit more expensive to monitor because you got to wait longer. And that's not really the culture that we all work in. We want to make decisions fast, and there's a good reason for that. But sometimes that means like having to say, no, I need to wait longer. How we deal with that, it can be varied. One of them could be exactly what Allon just talked about. It's like maybe MSPRT could actually be wrong for you if you're going to make a decision that the first answer you see that's statistically significant and then shut it off and never look again. So like one way to deal with that would be continuing to run it, keep looking, keep doing your peaking, but know that results may change, not because the analysis method was wrong, but because more data comes in later. Maybe usage behavior changes over time. Maybe there's a hangover effect. Maybe, or there could be some extra action your metrics are waiting for that it takes users time to do. Like classic examples are like sign-up experiments where like someone has to sign up and then it takes a couple of days for them to like come back or use your platform or have the need for your platform before they actually come back and use it. So you might make a declaration a little bit too early where you need to like wait a little longer. So thinking about like how often you check and being okay checking a couple times before you make your decision, that's one way you can deal with it. Another way to deal with these sort of issues of like maturity of data may be in how you define your metrics. I just want to call this out because it's always valid to talk about how you define your metrics, but not every metric has to be measured from the moment you start to get data on a user. You can define bake windows or windowed ways of measuring your data in which you say, hey, for some user in my experiment, I'm only going to count them towards the metric once they've been in the experiment for some minimum amount of time. That is another way to deal with these sort of like how do I call this like delayed measurement problems. I'm getting away from sequential testing, but that kind of metric is still perfectly valid in a sequential testing world. So it's not an either or situation. You can actually mix these methodologies that we have for how to define a metric, how to run my analysis to deal with surprises or interesting situations that you might have in front of you that you're trying to design a solution for.
Yeah, that's super helpful to have those examples, and also, thank you for giving some more generalized advice and takeaways there. I think that's super helpful. I know we have just a few minutes to go for the webinar. I want to, cover just a couple more items before we conclude. The first is, more for you, Michael, on just explaining what is the roadmap looking like for Statsig in terms of like innovating in sequential testing? I know you're working on some exciting stuff here, and you've been partnering with a lot of our customers as well on sort of implementing sequential testing. So I guess, can you just give us a high level on how we are planning to improve our platform with sequential testing methods in the future? And just also, I know you've already covered, the thought process behind why we chose MSPRT, but like if you want to just like tie it all together before we can.
Absolutely. I'll call out, and as part of this, I'm going to call out Sergey, one of the attendees. He asked a really good question, which is about this idea of the futility boundary. We currently don't have, because we don't use the group 6 for testing, we use MSPRT. MSPRT doesn't have this declaration of like, hey, you don't have a statistically significant answer today, and you probably won't. So you can end your test early, sort of the other way around. Like, can you reject the alternative and accept the null? MSPRT doesn't have that as part of the statistical framework. That's another one of the trade-offs I probably should have covered earlier. That said, there's other methods out there. These aren't the only two sequential testing methodologies, and we are actually working on additional methodologies here at Statsig that will open up the door to more flexibility in testing. I can't talk about the specifics yet. We haven't really announced them. But one thing I can talk about is how this has actually come from some of our customers. We work really closely at Statsig with customers, and some of them have specifically asked for, hey, do you have sequential testing that could allow us to say, hey, there's no difference between test and control right now, and the chance of there being one seems to be really small. Can we end it early from the other way around and sort of accept the null, which in traditional hypothesis testing is something you never talk about. Turns out there are ways to do that. There are methodologies out there in literature that have been proven. And so we're actually working on implementing them here at Statsig. And that'll really give, I think, our customers and even another tool in their toolkit for making early decisions that are trustworthy without raising their type 1, type 2 error rates.
Nice. I'm also just dropping our link to the Slack community. So for, like Michael mentioned, he works pretty closely with a lot of our customers, in often partnering and co-creating some of these methodologies into the platform. You can obviously connect with Michael on LinkedIn as well, but Slack is a great way to reach out to any member in the Statsig team, DM us, chat about the challenges or problems that you're solving for. Michael made a great post a month ago about one of our customers, Atlassian, who flew in from Australia to work with the Statsig team for a few days in building out some interesting stats methodologies. So just kind of reinforcing the idea that I think with the Statsig platform, a lot of the value in the platform has come because of building these very deep relationships with our customers, and all of this is in service of the product, right? So we work with our customers so that we can then understand more scenarios and then implement that in the product. So just a mini plug for Statsig there. But you can definitely reach out to us on the Slack that I've dropped on the chat. I guess my final question before we conclude, and this is for you, Allon, any advice you would give to someone who's just starting to learn about sequential testing, trying to get started with implementing it in their A/B testing framework? Any tips or resources that you can point us to, hot takes even, that would be helpful to conclude the webinar.
Yeah, so I think it really depends on the persona. So if you're really interested in theory, I would just start with some blog posts, which are relatively easy to digest, and also documentation from the A/B testing vendor. So Statsig have nice blogs or articles about MSPRT, and you can get from others vendors what they wrote about them. And there are some, I don't know, blog posts. Spotify has one that compare between both and tell you which one is suitable to each use case without getting really deep into the statistic, because I need to be honest, I don't know, I know the statistic, but not that deep of both of them. And I don't think it really matters. Now, this is in terms of understanding them better. But if you are interested in doing them in practice, I would start with one that is inside a platform. So, for example, using Statsig, because if you don't have the statistical knowledge, it might be a bit hard. It will take you maybe more time than just starting by using some kind of calculation or using a A/B testing platform that have this capability built inside. That what I would do in terms of getting practical, being able to do sequential tests fast. And at the end of the day, you can get, if you want to be really expert, you can read some of the. I think you also have the formulas in your documentation regarding the MSPRT. So if you really are into the statistics and formula, you can actually try and do it by yourself. Both the group sequential testing and the MSPRT. They are, you can use some kind of documentation or look at an article and do that. I can also give you some links for, I don't know, good blog posts or nice articles that really helps you to do that by yourself. But I wouldn't start with trying to do it by myself.
Yeah, good call out, Allon. I was literally typing that up. I wanted
Mhm.
everyone to know that if you know, if you don't use Statsig, that's okay. You could literally, if you're comfortable in doing a little bit of Python or maybe even in SQL, you know, in your day job, I've added the link to our open docs, where we've just laid out our exact methodology, the formulas we've essentially used, where the paper it all comes from. But you could literally implement this on your own company if you're looking to do so as well.
That's amazing. That's really, really amazing.
Nice. Well, thank you, Michael and Allon, for, really engaging discussion today. I think we've kind of hit on like everything we wanted to, talked about, the two main approaches for sequential testing, the trade-offs, just why this is important in the realm of A/B experimentation. Michael covered a bit about Statsig's approach to this and, just how we think about this as part of our framework. I think we've addressed all the questions that were asked on the chat as well. Maybe we can just hang out for like, 30 seconds to see if there's any, pending questions from our audience. But other than that, thanks so much, Allon and Michael. Allon is joining us from Israel. Michael is obviously in our HQ in Bellevue, Washington. And I know we had people attending from all around the world today. So thanks so much, everyone, for joining us today. You can stay in touch with us on Slack. And maybe Allon and Michael, if you also want to just drop your email on the chat, that might also help folks reach out to you directly.
Sure, no problem.
Yeah.
Absolutely. Makris at Statsig, real easy.
Nice.
If you can spell if you can remember how to spell Makris, which is always everyone's. Oh, you know what? I think both Allon and I are sharing it just to us. Hold on.
Yeah.
Oh, that's true.
There, everyone. Sorry.
Nice.
Wait, I'll try to do.
And thank you Sid for putting this together. Really appreciate it.
Yeah, no, it's awesome to see like a great turnout today. Very engaging discussion. I think it's always awesome to have the perspective both of like a vendor as well as like, like a consultant or a technology partner. So I think it's a very enjoyable discussion. So thanks, Allon and Michael, for doing this. And hopefully we can organize one of these again very soon.
Looking forward to it.
Yeah.
Thank you so much. Bye-bye.
All right, everyone. Bye for now.